Hey, I just wanted to show you what I've been doing with the computer vision. I've kind of gone into a different direction than where I was headed before. Um, so right now I'm kind of just investigating some existing algorithms that are out there, and I found a really interesting one that I've been playing with. Um, it is called grab cut. And well, really, it's just more or less the general technique is called graph cuts or graph cut segmentation for computer vision. Um, but grab cut is one of the specific techniques. It just happens to be in OpenCV as a one-liner, so yeah, uh, you can play with it there. So I'm playing with it here. One thing I will say is this is slow. Um, using this implementation, I don't think I'll be able to do it real time. But I will say that as far as I know that the graph cut part of this algorithm can run fast. The other part, I'll get to that in a minute. I don't understand it enough to know whether or not it can run fast. But so I'm gonna show you what it does first. And so it's basically one of the tools in Adobe Photoshop. It uses like the exact same algorithm. I don't need a gradient. Alright, so basically you have this input image, and we're going to generate output image. This is just for comparison over here. I just left the code there. You can kind of compare the dynamic range of the two techniques. Actually, we'll refix those sliders. There we go. And so this grab cut technique method, it's kind of unique because, well, I mean, almost all computer vision algorithms require an image input, but this also has extra input, which is from the user, so it's interactive. And basically the way it works is well, I've got it set up where you can draw with the right mouse button or left mouse button. Left mouse button will set it it'll kind of mask it as green, and then also set it as you're marking it as the subject or the foreground, and then you kind of make marks in the background to split. So I'll show you what I mean. So I'll mark Elena as the subject, get her face in there, and then you just you can mark the background a couple times. And this is acting as basically like seeds to this algorithm, because what it really is a mask. So it's just it's a four-state mask, but the user only writes two of those states. So let me just run this, show you what it does. Cool. Oh man, I didn't quite get her there. What about now? You see how slow it runs? Like it's not very fast. So yeah, I mean you can and so basically what it does is it actually, let me stop it because it's kind of making my computer loud. Let me I'm looking for a good place to start. Probably should start with explaining what the heck graph cuts are. They sound really complicated. They're not too bad though. I'm using the implementation that they use in this paper. There's a good picture. Oh, that's experimental stuff. Where is illustrations? here they go. So what I had was, what I was working with before was a situation where I had, you know, basically it's called a grid graph, just in the image space, where all the pixels are connected to one another. And so it's similar to that. Now mine had all sorts of other stuff going on with 9x9 units, and that's nonsense. This is on a per pixel basis, and the what you have though in addition are these two, I guess you could, I mean, you guess you kind of call them virtual nodes, but like these nodes are in a graph, like a traditional, how you would graphify an image. And then this, which is called the source node, it's got an edge connecting it to every pixel. Likewise, the sync node has edges connecting to every pixel, or rather from every pixel. And basically what you do, from my understanding, is you, for the weight of these edges, so the adjacent pixels and the adjacent edge connections, you can use, for instance, like the image gradient. So I mean, that's fairly convenient. So if I'm at this pixel, assigning it to this neighbor, I would set the weight of this edge to the gradient at this pixel, if that makes sense. And so like that's what you do there. Now this is the part where I don't have a clue how it works, but I'm trying to figure it out, because it's really freaking cool. It all comes down to the magic of the functions you use to assign these weights. Because what it's going to do is you're looking for a minimum cut of this graph. But it's weird because it actually solves it via maximum flow, because there's this theorem that's like, oh god, I don't know I can't really explain it, but it's just like the maximum flow basically is equivalent to or leads you to the minimum cut, because the cut is a set of edges that, when removed, separates S and T from one another. And so, yeah, I'm still trying to figure it out exactly how it works, but that's the gist of it as far as graph cut goes. Now, as far as this, what I was showing you is actually, it uses graph cuts, but it's actually called grab with a B cut, which is really confusing. But grab cut is basically a sequence of different operations, and it involves using the graph cut. But basically, what it uses to assign those edge weights for the source and sync is really cool. So it's like a probability. It's the probability that that particular pixel is a part of, say, if this is the foreground, or the probability that a particular pixel, well, that same pixel also has a probability that it's a background. And this probability is, they use this thing, which is like what I'm really interested in, I just don't understand it, is using a Gaussian mixture models. So yeah, so what it does is it takes that input mask, which are basically the marks you made as foreground and background as input initially, And then it's kind of like, if you know what an image histogram is, where it's like the distribution of intensities, it's like the same thing. I'm thinking of it like the same thing. Correct me if I'm wrong, because I have no idea. But it's like a histogram on a subset of pixels that you select. But there's more to it than that. But anyways, it creates this, from the set of pixels you select, it'll create this model that is apparently 65, basically a length 65 array of integers, or values. Like, I don't have a clue how it works, but in those 65 values, like, somehow it encodes, or you're able to then take a pixel at random and then just assign a probability of it being foreground or background, which is like nuts. So I'm really interested in that, but it's my first time ever seeing it, so I gotta figure that out. Yeah. And well, what GrabCut does, which is interesting, is that it's designed to be iterative in nature. So basically, you can feed its output back into the input. Best way to describe that is to see this. So that's the image going in. This is the input mask. So it's just another image that's the same size, and it just encodes the user selections. And then this is your background model and foreground Gaussian mixture models. But basically, the mask is an input and an output. And so are these. These models are persistent. So if I was to just like run it again, so to speak, it's not gonna be the same, because this mask will have changed. So that mask changed. You run it again, the mask will change again. And so basically what it would do is, right now this is the iterator counter. I just got to set to 1 because it's already slow enough. I don't need to go no slower. But basically, it's designed where it sort of can like converge to the edge, which is really cool. But beyond that, it's that characteristic which kind of got me interested in it, because there's a lot of applications for that, especially for what we'll be doing with the computer vision out there. So let me find some other images. Let's just do this one. So let's see if I can get this right. I got this Bluetooth mouse that likes to jump around. Alright. Background. There, we'll mark. There we go. Let me run this. I was hoping I could show you like one of the cool things about it. Cool. Nice. So you see that basically from what I selected, it kind of it kind of converged onto this. It's just the wood in a certain direct sunlight or in a certain lighting condition, because there's parts of the wood which aren't there because the chair is casting a shadow onto itself. But what I was going to show you, which is really interesting, is I didn't make any marks on this umbrella, because you can see that in the original picture that the stem of the umbrella is fairly heavily shaded until it gets up here where you have a lot of I'm guessing that's just diffuse light coming from in there and reflecting off because it's white. So yeah, it's probably just diffuse light in there, but because it's illuminated and it looks like the wood, it selects it. And so I kind of found that out by accident because I didn't really know that's how it worked. I thought that I was thinking more in terms of like the pathfinding algorithms that I work with, where it, it's going into this image, but it's not. It's because that Gaussian model is like a feature space almost. And like one of the things you can do with it, see if I got a good picture, is you can basically very easily classify different objects without having to rely on a neural network. Instead, you can just use fancy math. So for instance, here, see if this works. It's not so hot. I was hoping it would light up all the barrels. That's what I was hoping for. No, that might not work for me. I may have been using different settings or a different number of iterations last time, I'm not sure. But let's try a different version of that. Well, this is the one where I can show you. I mean, the thing about it though is it's not really an edge detector. let's see here, background, 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 definitely background. Well, you can see some of this stuff happening here. Like, so I mean, like it converges on that right there, which is a lane, but then like it also captures that truck, which we didn't select. And another thing that sucks is like this algorithm really has like basically like, so all these people in this picture frame would screw this algorithm completely up. Having all this, the amount of the amount of color complexity and texture complexity and how many different scales of that you have affect how long this thing takes to run. So I wish I could find a picture where it was like from a robot's point of view, looking at the course without anybody in its way, because you know that like when they're actually running the robot, nobody's standing in front of it, getting in the way of the vision. And I just can't find a good representative photograph that'll work for that. But what this does do is at least it proves that you can detect edges with it. And that the output of that is now a new Gaussian model. So we now have, if we ran it again, we would have a new Gaussian model for what constitutes a lane, and a new one for what constitutes grass. And because it's going around a course, and it should be, I mean, if you calculated the model a couple inches ago, and you move forward a couple inches, I mean, that model's still good. But the main thing is that it would be some way where if I could get it to work, you know, you would start the robot and you would do what I'm doing here, but then it would just converge onto the lanes by itself. And so it could be a way of adaptive, being able to adapt to different conditions. And I do wish I could find a good one that's a good one that shows you can use it to basically identify barrels. I just really suck at using paint programs. And this mouse isn't very good. Let's try it. Yeah, that's not bad. Let's see what we got. Look at that. All right, cool. So yeah, now we got so you should be able to barely see the strokes I made. So I made some strokes there, a little bit over here, but like it picked out all of these barrels as being barrel looking. That's cool as hell. I want to figure out how that works. So if anybody can help me with GMMs, Gaussian mixture models, and this dude. This is where they assign the weights. So the weights of these edges and the weights of these edges. come from that sucker right there, and you know, I don't feel like getting into that, so I'll see what I got. I will say that I do have this raw graph cut. I've got it working. I'm using this guy's implementation. It's the fastest one out there, and I will say that it runs really fast. Like I did like a basic run where instead of using that Gaussian model, I just do this other thing that's just so I could test this, and kind of cheating really, but like it runs really fast. Definitely possible to run it real time. It's just that I got to figure out some of the math here because I don't get that. All right, cool. I appreciate you watching. Let me know if you have any questions, ideas, concerns. Peace out.